Hey, dear class, we're going to look at the 11.2 notes the parabola. So this is the first of the three conic sections we're going to discuss. We're going to look at the parabolas with a vertex at the origin, and then parabolas moved out into the plane that have a vertex HK, which means it's not at the origin. All right, a parabola is just a collection of all the points in the plane that are the same distance from a focus as they are to a line called a directrix. So here's a picture of it. Here is our focus, that red dot. Here's the directrix, some line in space. And the parabola is all the points that the distance directly perpendicular from that point to the directrix is equal from that point to the focus in whichever straight line direction to the focus. So these two distances, the black line segments, are the same. And as that point moves away, it has to get further away from the directrix as the distance from the focus grows. So that's what cuts out this parabolic shape. So when we are looking at parabolas, the two forms we're going to see, they only show one on this slide, but there'll be two forms. There'll be y squared equals 4ax, and there'll be the one that's a little bit more familiar to you that has x being squared and y not being squared. So that's like good old y equals x squared that we saw in classes before, and that was a parabola. If you graphed it, right there's the x-axis, the y-axis. That parabola kind of looked at a U-shaped graph, a parabola. And that's the one that we're used to when the x is squared and the y is not squared. But when it's reversed and y is squared and x is not squared, then that's just going to go left or right depending on the sign of a. All right, if a is positive, it opens to the right like this. If a were negative, it would be flipped over and it would open to the left. All right, when we graph a parabola, the reason why it's in this form is because the 4 tells us the number that we multiply by is how far we move off of the origin to find our focus and our directrix. So with this 8x, for instance, we're at the origin because there's nothing being added or subtracted here from x or y. But because 8 is 4 times 2, that means we need to move 2 units to the right, and that'll be our focus. And then if we move 2 units to the left, we get our directrix. This would be at 2. This directrix over here would be at negative 2. And the parabola, the collection of actual points, starts at the origin, which is the vertex. It's right in between the directrix and the focus. And it moves away from the directrix towards the focus, so it would open in that direction. Now technically you need 3 points to make a parabola, to draw a parabola. We have one right now, the vertex. The other points, if we go directly above and below the focus, those points are 8 total units away, whatever that number. The total distance from the top red point to the bottom is 8 units, so it's 4 up and 4 down. So that number that's in front of x is the total distance from this red point down to the other red point. This green distance here is called the latus rectum. Unfortunate name, but that's what it's called, and that is the 2 extra points that you get that will give you the 3 points needed to draw a parabola. Okay, so again, the quick way to get those points, you can do all this math that it's showing you to do here, plugging in the focus, but the key thing is whatever the number is here, 8x, if it had been, for instance, 12x, I would have gone 6 up and 6 down, because 6 plus 6 is 12. If it had been 100x, I would have gone 50 up and 50 down. That's basically, that number is the total distance from the bottom point to the top point. All right, the TI could graph y squared equals 12x. You would just need to solve for y, because again, in rectangular coordinates, it's y equals on the calculator. So you would have to solve that for y, and because of the square, you'd have a positive square root and a negative square root. All right, let's look at one where x is being squared. So when x is being squared, that's the ones that we're used to. Because of this negative, that means that this is going to be one where we open downward. Okay. A is, we can remember, it's 4ay, and it's negative technically. So a is 2 here. So the focus is going to be down below because it's negative. And the directrix is going to be y equals 2. It's going to be a horizontal line this time. But because it's negative, it's above the vertex. All right, a latus rectum is going to be 4 units to the right, 4 units to the left, because of the, again, they need to add up to 8. So 4 to the right, 4 to the left, vertex at the origin. Right, and then this is 0, -2. All right, that's 0, -2. Again, 4 to the right would be -2, or -4, sorry, -2. And then this would be +4. All right, so there is the drawing of that. Remember, your latus rectum will always have that distance. That is the coefficient of the number in front of the variable that's not squared. So in this case, it's the y. All right, Desmos could graph this without doing anything. It could graph the original 2 without doing anything. The problem is you're not allowed to use Desmos on the final exam. So get used to solving these for y. So you could do this with a calculator, the TI calculator. You just need to get the y equals to plot that. All right, what if they give me just the focus and the directrix? How do I come up with what this thing would look like? So it's telling me that the focus is 0, 3. So that's up here on the y-axis. The directrix is y equals -3. So that's down here. So that means the origin, which is right in between -3 and 0, 3, is my vertex. And remember, we always go in the direction of the focus. So we're going to open in that direction. So it's going to look like that. Okay, so we know it's going to be x squared equals 4ay, and we also know that y is 3. So this is x squared equals 12y. All right, that's the point 0, 3. So if this is 12, that means we have to go left 6, and we have to go to the right 6. So that would be -6, 3. That would be +6, 3 for that particular one. All right, so there is our graph. This is labeled wrong. I noticed when I was preparing these, that should be 0, 3, not 3, 0. That's just a image that Pearson that made these slides made an error on. All right, everything else looks fine on it though. All right, now it's starting to be a little bit more obscure what we need to do when they're just giving us a point and an axis of symmetry. But just remember, the axis of symmetry is the axis that this thing folds over on top of itself. So if it's the x-axis, that means this thing is going to go in that direction. All right, now that direction, or now that I'm looking at that point that it gives me, it's actually going to go in this direction. The reason I know it is because -1/4 would be in this direction. So -1/4 1 is to the right and up, so that means that parabola would need to open to the left. All right, and then that means that would also be there, -1/4 -1, because again the x-axis is the axis of symmetry. So we'd also get up -1/4 -1 would be a point on there. All right, so we know that y is what's squared, and it's equal to 4ax. We also know that if we square the y-coordinate, 1 squared or -1 squared is 1, is equal to 4a, and then -1/4 is on there, -1/4. So you can see the 4 and the -1/4 will cancel, and that leaves me with a times -1 equals +1, which means a is -1. So if a equals -1, that means the equation is y squared equals -4x. All right, a being -1, that means that we have a focus at -1. Our directrix is x equals 1. Right, and technically the lattice rectum here, because the number in front of x is 4, we would go up 2 and down 2 to get those points on the lattice rectum. All right, and so there is our graph of our parabola. Now what happens if we move these things into space? Well, the answer technically is nothing. All of it stays the same. Our analysis stays the same. It's just the origin gets shifted, and that kind of shifts like where the x and y axis are. But the way that we proceed, like a moving to the left 2, right 2, or up 2, down 2, depending on what's squared and what's not, is the same. It's just we're shifting where that vertex is. We're shifting things off the origin, but we still have the same process. So this is the new vertex. So the new origin are these HKs right here. But everything is the same. Like, look, we just add a. We subtract a. We move a units to the right, a units to the left. We move a units up, a units down. It just all depends on who's squared and who's not, and which way we move. It's just the same thing. It's just the origin is now HK. So let's see what happens here. We got here's our XY plane. Our vertex now is at the point 1, -2. So there's our vertex. And our focus is at 2, -2. So what does that mean? That means we went right 1 and got our focus. So that means we're going to go left 1 and make our directrix. That's going to be the y-axis. And that we're going to move from the vertex in the direction of the focus. So we're going to go in that direction. It's going to open to the right. So that means this looks like this. Y squared equals 4ax. But we shifted. How did we shift? We went right one. That means this is going to be, instead of x, it's going to be x minus 1. And we went down 2. So that means instead of this being y squared, it's going to be y plus 2 squared equals 4ax minus 1. So we just apply the shift to the x and the y in the parentheses, and it's the opposite of these signs. Basically, if this is a positive, then we subtract. If this is a negative, then we add. And we do the same thing if the signs were flipped. I mean, if this had been a negative 1 and a positive 2, this would be a positive 1 and a negative 2. Alright, so there's our equation. Again, we simplify it. Y plus 2 squared equals 4x minus 1 squared. Definitely don't square out that y plus 2, and I wouldn't even distribute the 4 through. It's perfectly fine to just leave it in that form. Alright, again, the latus rectum is up and down in this case from the focus. So because our focus was at 2, negative 2, and we go up and down from that, the number here was 4. That means we have to go 2 up and 2 down. So it was 2, negative 2. So going up 2 would be 2, 0. Going down 2 would be 2, negative 4. So it's still, again, same thing that we did before. It's just everything's kind of shifted. But just we move, to get the points on the latus rectum, we move off the focus based on that coefficient in front of the thing that's not squared. Okay, this is to the first power. So it's that number in front of the x minus 1 in this case that determines how much. Again, half up and half down. So 4, 2 up, 2 down from the focus. Alright, if I wanted to check my work, I would need to solve that for y. So it's a little bit more involved when we have these shifts in the graph. When we are not at the vertex, is not at the origin. We have to do a little bit more to solve for y. Alright, this is two different y's. It's negative 2 plus that radical and negative 2 minus that radical. So that's what it would look like if I graphed it. Alright, again, Desmos, you don't have to solve for anything. You just throw it in there how you want. But because the technology you're allowed right now on this exam is the TI, you have to, if you want to graph it, you want to see it, you need to use the TI. Alright, when I'm looking at this and I want to come up with what is this parabola in that 4ax, or in this case 4ay form, I would need to complete the square, because I need to have an x plus or minus something squared and a y plus or minus something. So to do this, the first thing I'm going to do is complete the square on that x component. That's going to have me isolate the x and the x squared terms. So to complete the square, I take half of that negative 4 and square it, and I add that squared number to both sides. So half of negative 4 is negative 2. Negative 2 squared is 4. So I'm adding 4 here. And so I have to add 4 here to keep it equal. And so this on the right hand side, it's just going to be 4x plus 1 if I factor out a common 4 here. And on the left hand side, that's the completed square. That's x minus 2 squared. So now I have the form that we need for HK version of the vertex. So the vertex here is going to be at 2, negative 1, and then 4a times x plus 1, or y plus 1 in this case. So that means a is 1. All right, because it's x squared and y is to the first, this is going to be opening upward because it's a positive 4. So right 2, down 1. All right, and then because this is a equals 1 here, that means the focus is going to be right there on the x-axis. The directrix is going to be below it, and y equals negative 2. I'm going to move away from the directrix towards the focus. All right, the focus is right there at 2, 0, and the number in front here is 4. So I'm going to go left 2 units, right 2 units. So technically that should have gone through the origin, right 2 units. So again, same thing. That's how I get the latus rectum. I move back and left and right in this case from the focus. So you can see where we go through the origin, and that's left 2 units, and then go right 2 units to hit the 4, 0. All right, the big application for parabolas are reflective light, and then things like a satellite dish, especially a satellite dish, because it has the focus is basically a little part that sticks out of the dish that you see. So there is a light, like a spotlight. There is a telescope, and then the big one, the satellite dish. So we have the parabolic shape. we also have that little part that sticks out, and the end of that thing is the focus on the satellite dish. Alright, so the question here is, if the dish is 6 feet across and it's 2 feet deep, where is the focus on that thing? So you can see what we've done here is we've centered it at the origin just to make the math easier than having some HK center. And there is the 2. And you can see that we've gone to the left 3 and the right 3 to get that 6. Right, so that means the focus is going to be, because that's like our latus rectum, right? That means the focus is going to be the value of A in this equation when we plug in either of these points on there. Okay, because again, anything that an x coordinate and a y coordinate on there are part of the parabola. So I can use any of those. 3, 2 on there. I can square 3, put 2 in there for y, and that gives me an equation I can solve for A. Alright, so A is, in this case, if you do the math, 9/8 or 1 1/8. So we should put it about 1 1/8 feet from the base of the dish.